Lesson 6, Topic Geometric Proofs, Part 1. Learning target, I can write proofs using geometric theorems. First off, some vocab. A proof is a logical argument that shows a statement is true. Two-column proof gives numbered statements and corresponding reasons that show an argument in a logical order. The reasons that we can use in our proof can include definitions, properties, postulates, and theorems. So a proof is just a logical way of explaining why the math that we can do is valid, is true, and why it works. So we're going to jump in. We're going to complete the proof. We are given that AC equals AB plus AB. So prove that AB equals BC. So the first thing that I like to do is I like to make sense of the diagram and the information that is given to me. And sometimes I do that by just applying some numbers, so it helps make sense in my brain. So the first thing I'm going to make sense of is this AC equals AB plus AB. So AC is that whole stretch. So if that whole stretch was, let's just say 10. So let's say AC equals 10. Then AB would have to be 5 because 5 plus 5 equals 10. So then I want to prove that AB equals BC. So then AB would be the same thing as BC. So then BC would also be 5, which should make sense because AB plus BC has to equal this whole AC, which then would have to go back to that 10. So kind of making sense in my brain, making sure I understand what I'm trying to prove, and then we walk through the proof. So the first statement, number 1, is always what we are given. So we are given that AC equals AB plus AB. The reason is just given. So now I've given you all the statements, and we're just going to think of the reason why we can make those statements. So building up that proof stamina. So we have AB plus BC equals AC. Well, why can I say that this segment plus this segment equals the whole segment? You remember we have our segment addition postulate, which tells us that the two segments that make up the whole can be added to make the whole. So now we look at statements 1 and 2. We can see that AC equals AB plus AB and AC equals AB plus BC. So I have two different things equal to the same thing. So that means I can take those two different things and set them equal to each other by what we call our transitive property of equality. Remember that crisscross? So we have that crisscross. These two things are the same. So then I can set the other two things equal to each other. Now if we look on both sides, we have an AB. We're adding an AB on both sides. So if I subtract AB on the left and I subtract AB on the right, we can get BC equals AB. And that is just our subtraction property of equality. We can subtract the same thing on both sides. So right now we have BC equals AB. We wanted to prove that AB equals BC, so we can flip-flop around the equal sign. And the reason we can rewrite it that way is just that symmetric property of equality. And now we've logically explained why if AB plus AB equals AC, then AB equals BC. All right, let's do one more practice problem. Prove this property of midpoints. If you know that M is the midpoint of AB, prove that AB is 2 times AM and AM is 1/2 of AB. Let's make sense of that. If M is the midpoint of AB, it's cutting AB in half, meaning if AB is 6, AM would be 3, MB would also be 3. So then if we look at this, AB equals 2 times AM, well, AB is 6. Does it equal 2 times 3? AM is 3? Yes, it does. AM equals half of AB. What's AM? AM is 3 equals half of what's AB? 6. What's half of 6? Half of 6 is 3. So using those numbers, we can logically make sense of why that's true. And now we're just going to logically explain why it's true. So again, we always start with our given. Statement 1, M is the midpoint of AB. That is given. So then if we look at statement number 2, AM, segment AM is congruent to segment MB. Well, why can we say that? Well, it's right there in statement 1, midpoint. What's our definition of midpoint? That it splits a congruent into splits a segment into 2 congruent pieces. So that's just your definition of midpoint. Then from statement 2 to statement 3, we go from congruence to equality, and that's just our definition of congruent segments. If 2 segments are congruent, then their measures are equal. So we can say that AM equals MB. So now we have AM, this length right here, plus MB, this length right here, equals AB, the length of the whole, and that is again that segment addition postulate, which says that the 2 pieces that make up the whole can be added together to equal that whole piece. Then if we look from statement 4 to 5, we're changing MB to BAM. Well, why can we change MB to BAM? Because they're equal. They're the same thing. So that is our substitution property of equality. We can substitute one equal thing for the other. And then if we look from statement 5 to statement 6, we've taken AM plus AM and made it 2AM. Well, that's just like doing x plus x is 2x. It's just combining those like terms. A simplification piece, which then leads us to proving our first piece that says AB equals 2AM. Because by that symmetric property, we can say that those 2 things are the same thing. And then if we just take that 2 away from AM by division, divide both sides by 2, which we can do by our division property of equality, we get AM equals 1/2 AB. So that is the end of your notes. You can go ahead and move into your practice.